Hey everyone, welcome back. Today we're going to be talking about one of my favourite topics in auto mathematics, and that is vector spaces. Which sounds complicated, but we'll take it step by step, and I'll show you it's not really that complicated. So a vector space consists of four parts. It consists of two sets, V and S, and two binary operations that we will call star and plus. Now V is the set of vectors, and it can be pretty much any set you want. The second set, S, is called the scalars. And for us, we're going to take it to be always either the real numbers, which we wrote with this fancy R, or the complex numbers, which we wrote with this fancy C. Now, the first binary operation, plus, is just a map that eats two vectors and gives us back a third vector. So it allows us to add vectors. Now, the second map, this star or multiplication map, eats one scalar, so something from S, and eats something from V, and gives us back something else in V. Now, these do have to obey some special properties, but before we talk about that, let's just talk about some simple examples that you might have seen before. So, one simple example of vectors are just columns of two numbers, say 1, 2, or 3, 4. And these form a vector space we call R2, where V are these columns that we call R2. S is just normal numbers, R. And addition works in the way you expect. So, 1, 2, plus 3, 4. You just add the 1 and the 3 to get 4, add the 2 and the 4 to get 6. And our star operation works also in a similar way, where 6 star 1, 2 is 6, 12. Now, we can make our columns as big as we want. We just call it Rn, where n is the size of the column. Now, let's talk about the properties of addition, properties of our addition function. So, the properties of vector addition are, firstly, it has to be associative. Now, all this fancy word means is if I do u plus v plus w, this has to be the same as doing u plus v and then adding w. E.g., it doesn't matter what order we do the addition in. We can just put our brackets. It doesn't matter whether we do this first or this bit first. The second property is that it has to be commutative. And this says that u plus v is the same as v plus u. E.g., we can kind of swap order in which we do stuff. So it doesn't matter whether we do 5 plus 2 or 2 plus 5, we get the same answer. The next property we need is a bit weird, and it says that there is a zero vector. That means there is some special vector we call 0, so that when we do v plus 0, we always get back v. No matter what v is, when we add this special 0 vector to it, we get back v. It's important to note that this 0 here lives in the set of vectors. It lives in the v set. It doesn't live in the set of scalars. The other important property we need is what's called inverses. What this says is for every vector v, we can find some other vector w so that they add up to 0. And we'll often write w as minus v. Now, let's talk about the properties of scalar multiplication. Now, the first rule for this multiplication is that 1 times any vector just gives us back the vector. It doesn't do anything. The second rule is that a star b star v is the same as doing a times b, then timesing the whole thing with v. And then finally we have the rule that says if we do a plus b star v, we get a times v plus b times v. So it allows us to expand out brackets. Finally, we need to talk about how do scalar multiplication and vector addition interact. This means we need the following really important property. That is a times u plus v is a star u plus a star v. Now you might be wondering how this differs from this one up here that we just talked about. Well, the important thing here is that a plus b live in S. They're scalars. Whereas here, u and v are vectors, they live in v. So we need both of these rules. So that's sort of a summary of the basics of vector spaces. And don't worry if it sounds very abstract. We're going to look at some more examples as we go, and we'll get very familiar with it. Thank you all for listening.